Hello dear students, we are studying the variations into oxidation states. We have seen that the stability of -2 oxidation states decreases down the group, and oxygen is the most stable oxidation state. For oxygen is -2 because oxygen is second most electronegative element. -1 oxidation state in oxygen is called peroxide. This -1 oxidation state is shown in the various peroxides like hydrogen peroxide, sodium peroxide, potassium peroxide, rubidium peroxide, cesium peroxide, calcium peroxide, strontium peroxide, barium peroxide, magnesium oxide, and some other transition metal peroxides. For oxygen, oxidation state of -1/2 or O2-1 ion is also possible in case of potassium superoxide, rubidium superoxide, and cesium superoxide only. So -1/2 oxidation state is possible only in case of the superoxides of potassium, rubidium, and cesium. O2-2 ion is called the superoxide ion. So this is how we really understand about the variation in oxidation states. There are only two compounds where oxygen show positive oxidation state, and they are OF2 and O2F2. So only OF2 and O2F2 oxygen is positive oxidation state. Sulfur, selenium, and tellurium shows +2, +4, and +3 oxidation state. Among these three, +4 and +6 oxidation state is more common. So out of this, these two are more common. +2 oxidation state is not much seen. Going down the group, stability of +4 oxidation state increases and +6 oxidation state decreases. This stability of +6 oxidation state decreases that can be explained by a particular phenomena. This phenomena is known as the inert pair effect. So due to inert pair effect, the oxidation state +6 oxidation state going down the group, the stability decreases. Sulfur, selenium, and tellurium usually show +4 oxidation state in their compounds, with oxygen and +6 oxidation state in their with fluorine. So when they form their oxides and when they form their fluoride, this sulfur, selenium, and tellurium, in their oxide they show +4 oxidation state, but in their fluorides they show +6 oxidation states. Bonding in +4 and +6 oxidation state is primarily covalent. So those compounds which are formed with +4 and +6 oxidation states, they generally form the covalent bonds. Now we are going to study a very important point, that is what it is known as the anomalous behavior of oxygen. Element that belong to period number 2 should be elements. Element belongs to period number 2, that is second period, are first element in P block for a group number 13, 14, 15, 16, and 17. For group 16, such element is oxygen. All these first elements of period shows anomalous behavior, so the oxygen also shows the anomalous behavior. The anomalous behavior of oxygen, like other members of P block, is due to small size and high electronegativity and absence of d orbitals in valence shell. Due to small size and high electronegativity, there is a strong hydrogen bonding in H2O but not in H2S, H2Se, and H2T. That is what it causes the many consequences. Due to absence of d orbitals, the valency of oxygen is limited up to 2 only, or maximum it can go up to 4, but practically the 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 valency of oxygen is seen up to 2 only. But those elements which have vacant d orbitals, they can extend their valency, and they can have their valency even more than 4, but the valency of oxygen is limited up to 4. I hope, my dear students, you are enjoying. Happy learning.